I hope you are doing fantastic. This is a video, I'm going to go through it. It's what we did in last lesson. I just thought I'd slow everything down, so you can have an idea of what is going on. So, let's absolutely skip this page. Let's ignore this for instance. Let's not confuse ourselves about velocity and speed and physics. Let's keep physics to physics. Let's go straight to the key points. Let's go straight to the most important thing. So this graph or this notes are the most important thing that you need to help you counter any question. So if you look at your units, you have velocity and you have time, then in your head you should be thinking this is going to be a velocity time graph. Alternatively, you should have speed here if that does not come in your lesson. So speed on this side and then that's it. Okay. So the gradient of the line is equals to acceleration. So the gradient of this is equals to acceleration. If you go up like this, we calculate the gradient, we get the acceleration. So if the gradient is sharp, like the black one here, then the car is traveling really quick. The car is speeding up. If it's like this, it is still speeding up, however, it is accelerating. It's getting faster. So this flat line means that the car is at constant speed. What constant speed means is that the car is traveling, here's my horrible drawings, the car is traveling at a constant speed, okay, at a constant speed. And it just basically means that it definitely understandable that it means the car is just continuously driving through the road at a constant speed. So imagine it says 80 miles per hour. No one's going to go over that. They'll stick at 80. It's constant. Does not change. Okay. So then we have the line going down. The line going down means it is going slower. So slowing down until it stopped. Imagine there was a traffic light here. So you won't stop here, obviously. You'd slow, and then stop in front of the traffic light. Okay, in front of the traffic light. It's very, very similar. Like your father won't stop stop straight away when he sees it. He'll get closer to it and slow, and then come to a stop in front of the red light. So these are very, very important. The last thing that you need to know is the area under this accounts for how long the journey took. So how long did this journey take? So if it's in meters, it's a distance. So we're going to look at two examples that should basically sort you out for the exam. So let's look at this. So this question talks about a car traveling a 50 seconds journey. Now this is important to understand what's happening. So we need to know, describe the journey. So the car is at rest. It accelerates, it's a positive acceleration, to a speed of 15 meters per second in a time of 10 seconds. Then the car is traveling at a constant speed. The constant speed of 15 meters per second for 10 seconds. Then the car decides to speed up again. It accelerates to 25 meters per second in a time frame of 10 seconds. Finally, the car decides to slow down and decelerates from 25 to 0 over a period of 20 seconds. That's what the examiner needs to see: clear, concise understanding and explanation of a journey. So you have to be able to explain what's happening in a journey. So now it says, describe it, find the acceleration. So the acceleration in every part is the gradient. Remember this, rise divided by run. So what is rise over run? We go up 5, 10, 15. So our rise is 15. Our run is going to be 1 and 2, and each box counts for 5. So it will be 10. 15 divided by 10 gives me 1.5 meters per second squared. Here we have a flat patch. So basically we're not rising. We have 0 divided by 10, which is equals to 0 meters per second. So you can write meters per second as ms to minus 2, or you can write as m over s squared, whatever you feel is right. So here 0 because it's flat, it makes sense. Next one, we do the same thing. We rise how many? 2 boxes. Each box is worth 5, that's 10. And then rise again, run for 10 boxes. So 10 divided by 10 is equal to, again, rise divided by run is 1 meters per second. 1 meters per second. Last, remember the rule I told you, if the line is going down, we require less power, which means it's going to be a negative. So straight away put a minus sign. Now apply rise over run. So we have 1, 2, 3, 4, 5. That's going to be 25. Divided by 1, 2, 3, 4. That's going to be 20. So our answer will be negative 1.25 meters per second squared. Okay. You can write it as ms minus 2 or m over s squared. Please be consistent which one you want. I prefer ms to minus 2 because it's one I don't have to write a fraction. So now let's look at the example of finding the area. Now the area is important that we be able to find the areas. We'll give you all the formulas you need. The area under is the distance traveled. Very, very important. So now we look at this. The area triangle follows as a base times height divided by 2. This is just base times height. This is a plus b divided by 2 times height. And again, base times height divided by 2 here. The height of this, therefore, would be 1, 2, 3. So that would be 15. And we multiply that by the base, that's going to be 10. And it says base times height divided by 2. That gives me 75 for the area of the triangle. This one with 15 times 10, which is equals to 150. And this is 5, 10, 15. So 15, add the height of this one. So 5, 10, 15, 20, 25. So we add the parallel lines, divide it by 2. That's the formula, and times it by the height. The height is 1, 2, which is 10. So 15 plus 25 is 40. 40 divided by 2 is 20. 20 times 10 is going to be 70. So 200. 20 times 10 is 200. Last but not least, this triangle will go with height. We know the height because it's the same height as trapezium. 25. The base would be 5, 10, 15, 20 times 20 divide by 2, which is 500 divided by 2 is 250. Adding 250, 200, 150, 75 gives us 675 meters. And we know it's meters because look at the meters, the units of speed. Units of speed is meters. So that's the solution there. Moving on to what we did in lesson, which is this one here. Again, we follow the same principles. We know the area under the curve is the distance. So let's find the first one. The base is going to be the base times height. So 1, 2, 3. That's going to be 15 multiplied by 1, 2 times 10. It's a triangle divided by 2. That gives me 75. Next one, we know it's the same height, so it's going to be 15. We know trapezium, you do the height of this one and the shorter side. So 15 plus 10 divided by 2 times the height 5. So 15 at 10 is going to be 25. 25 divided by 2 is 12.5, and 12.5 times 5 is going to be 62.5. And then another trapezium this time, we have a height of 10 and the second height of 20. So it means that at two sides, 10 at 20 divided by 2 times 5, the height at the bottom, it jumps in 15, 20, so each box is 5. 30 divided by 2 is 15. 15 times 5 is 75. Last but not least, the main one, it jumps by 1, 2, 3, 4. That's 20 on this side, and 1, 2, 3, 4, 5, 6. That's going to be 30 here. The 3 times 2 is 6. Add the zeros. So now adding this, 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 and this will give you 812.5 meters. So please, can you check that out? Now, that's it basically. That is all it. And it's just understanding how to find the areas of trapeziums. Knowing the gradient, it means the acceleration. Knowing that the area under the graph is basically the distance or displacement, same word. And knowing that if we're going downhill, it's a negative acceleration. If the line is flat, there is no acceleration, it's zero. It's constantly traveling at a constant speed. And that's it. I hope this video helps you guys, and have a fantastic day. And as always, toodles. Take care.